Question 21. ABCD is a parallelogram. We've got a couple of straight lines and a couple of angles that are 90 degrees. The writing here is just an explanation of the picture. So if you don't immediately understand the writing or understand the picture, try and link the two together. Part A, prove that triangle ADP, so I'll just label that in blue, A to D to P, is congruent to triangle CBQ. So this red one, C to B to Q. I can just put some dotted lines in so we can see the two triangles we are talking about. Some people like to draw them out. If that works for you, that's great. So I've got to prove that that blue triangle and that red triangle are congruent. Now, if you don't know what the word congruent means, you're going to find the question difficult. Congruent is the maths word for identical. And there are 4 ways of proving that two triangles are identical. You can show that all 3 sides are the same length, side, side, side. You can show that there's a side and an angle followed by another side that are all the same size. An angle followed by a side followed by another angle of the same size, or a right angle, the hypotenuse being the same size, and then another side. Sometimes you don't know which one you're going to use until you get to the end, but for this question, it's going to be angle, side, angle. You didn't need to spot that at the start. It's perfectly okay just to start off with what do we know and then get to the end. So we know angle ADP, this one here, is the same size as CBQ. Let me just change the colour a minute, just to help it stand out. ADP, so this one, is CBQ, this one here. Okay, so angle ADP equals angle CBQ, then 90 degrees, and we were given that, we were told it, so that's part of the proof. So I've got the angle bit. I now need to come up with a side followed by an angle to complete the proof. We're told here that ABCD is a parallelogram. So this side, BC, and this side, because they're a parallelogram, they must be the same length. So BC equals AD, because opposite sides of parallelograms are equal. I should have said at the start, sorry, after this first statement, you have 1 mark. So now I've got an angle followed by a side. I just now need to work out the other angle, or show that that is the same. And then I have proved the congruency. Now angle PAD, this one here, and BCQ, this one down here, they're going to be equal. So you need to know quite a lot about parallelograms here, but these opposite angles are the same size. So angle PAD equals angle BCQ as opposite angles of parallelogram are equal. Now that I've got all 3 statements down, I've got my second mark. I've done angle, side, angle. You must state which form you've used. So triangles are congruent due to ASA, angle, side, angle. And that statement gets you your 3rd mark. Let's have a look at part B. Part B, explain why AQ is parallel to BC. So let's go back up. I've cleared off the picture from part A just to make it a little bit easier. So it's saying, why is AQ parallel to PC? I'll just put part B here so we can see the picture and the workings at the same time. Now we know from part A that AP equals QC. We've just worked out that these triangles are congruent. So the hypotenuse of both triangles, A to P and Q to C, must be the same length. I'll just put a little explanation in that AP and QC are hypotenuse, or the hypotenuses of triangles just shown to be congruent. And that gets you a mark. And I'm going to have to finish it up here because I'm running out of room. Therefore, AQ equals PC as APCQ is a parallelogram. If these two sides in green are the same length and they're parallel, the line joining the end of both of them and the line joining the start, they must also be parallel because it's a parallelogram. And there's your 2nd mark. Well done if you got this far. I hope you've enjoyed it, and best of luck in your exams.